Okay, students, moving to the seventh problem. Okay, now listen the problem. Find the focal length of a convex mirror of radius of curvature 1 meter. Okay, now we have to find the focal length of the convex mirror. So convex mirror means we should get the ray diagram, right? Virtual and direct image. So here what they have given is radius of curvature is 1 meter. So focal length, radius of curvature, okay, principal focus, everything will come behind the mirror, means towards the right side. So the sign convention has to be positive. Why? Because we are moving in the direction of incident ray. Okay. So now I have to find the focal length of the convex mirror given the radius of curvature is 1 meter. 1 meter means positive sign, that is 1 meter. You have to find the focal length. Now, which formula you have to use? The relationship between focal length and radius of curvature. Therefore, F is equal to R by 2, or F is equal to 1 divided by 2. 1 by 2 means half, that is 0.5 meters. So, focal length will be at 0.5 meters. Okay. Okay, students, moving to the 8th problem. Carefully listen to the problem. An object 4 centimeter in size is placed at a distance of 25 centimeter from a concave mirror. So mirror is concave mirror of focal length 15 centimeter. Find the position, nature and height of the image. So an object 4 centimeter in size. An object 4 centimeter in size, which means the height of the object is above the principal axis, right? So h1 is equal to plus, that is positive 4 centimeter. Placed at a distance of 25 centimeter. So object distance, since it is concave mirror, it is negative, that is minus 25 centimeter. From a concave mirror of focal length is also given, that is also negative. So minus 15 centimeter. You have to find out the position of the image, means V you have to find out. Then nature of the image, then height of the image. H2 you have to find out, then nature of the image. Of course, in a concave mirror, except for one case, the nature of the image, you know that it is real and inverted. Still, we have to see. Now, you have focal length, you have the object distance, you can easily find out the image distance. That is, you can use this formula, F is equal to UV by U plus V, that is product by sum, that modified mirror formula. Therefore, from that, you can find out what exactly is V. Okay. So, F is equal to UV by U plus V. Here we have F is minus 15 is equal to U is minus 25. You don't know V, divided by U plus V. U is minus 25. Again you don't know V, you have to find out V. Then cross multiply it. Okay. So minus 15 into minus 25 plus V is equal to minus 25V. Okay. Now minus into minus is plus. So 15 into 25 minus into plus is minus 15V is equal to minus 25V. Now what you have to do? Bring this minus 25V to the left side and shift that to the right side. So what you will get? You will get 25V, that is this becomes plus, minus 15V is equal to minus 15 into 25. I have not multiplied, we shall simplify later. Now 25 minus 15 is what? 10V. So 10V is equal to minus 15 into 25, or V is equal to minus 15 into 25 divided by 10. Now 2s are 5s are, right? Then what you will get? 1s are
then minus 7 ja, then 2 5 ja. So V is equal to minus 7.5 into 5. 2 carry, 7 5 is 32 plus 37. So you will get minus 37.5. So minus 37.5 is the object distance or the position of the object. Okay. Now you can see here this is image distance. Image distance is minus 37.5 centimeter. What is the object distance? Minus 25 centimeter. Obviously, what is the nature of the image? Since it is being given concave mirror, so nature of the image is real and inverted. Nature of the image is real and inverted. Next you have to find out H2, that is height of the image. You have height of the object is given. Then you have U and V. Equate the equations, okay, the ratios of the magnification formula. So therefore we can use H2 by H1 is equal to minus V by U. Okay. Now you have H1 being given. You have to find H2. H1 is 4. Okay, is equal to minus of within the bracket minus 37.5 divided by U is minus 25. Okay, now cross multiplied. So what you will get? Minus 25 H2 is equal to minus 37.5 into 4, or H2 is equal to minus 37.5 into 4 divided by minus 25. So minus minus goes cancels. Suppose if you simplify this, upon that you will get H2 is equal to you will get minus this will be plus, okay, plus 37.5 because minus of minus is plus, okay. So minus 25 H2 is equal to plus 4 into 37.5. So you will get plus divided by minus. So you will get minus. So upon simplification you will get H2 is equal to minus 6 centimeter. So this is the simplification. H2 is equal to minus 6 centimeter. That is height of the image. Okay, is minus 6 centimeter. Why? The negative sign indicates that the image is formed below the principal axis. That's why it is negative. Okay students, moving on to the ninth problem. Just carefully listen. This was asked in CBSE 2017. A concave mirror produces 3 times magnified image on the screen. If the object is placed 20 centimeter in front of the mirror, how far is the screen from the object? Please think before going for the solution or before giving the answer. Now, concave mirror producing the magnified image. So what do you mean by that? Usually in concave mirror up to case 5, from 1 to 5, you will get real and inverted image. The size may vary, real and inverted image. Usually the size is diminished. But here in the problem they have asked that the image is 3 times greater than the object. ಅಂದ್ರೆ ಏನು, ಇಮೇಜು ಆಬ್ಜೆಕ್ಟ್ ಗಿನ್ನ 3 ಪಟ್ಟು ಜಾಸ್ತಿ ಎತ್ತರ ಇದೆ, ಜಾಸ್ತಿ ಇದೆ ಯಾವ್ದ್ರಲ್ಲಿ, ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಲ್ಲಿ. ಅಂದ್ರೆ ಇಮೇಜು ಯಾವ ಕಡೆ ಇದೆ, ಮಿರರ್ ಮುಂದೆ ಸಿಗ್ತಿದ್ಯೋ ಮಿರರ್ ಹಿಂದೆ ಸಿಗ್ತಿದ್ಯೋ, ಮೀನ್ಸ್ ದ ಇಮೇಜ್ ಇಸ್ ಫಾರ್ಮ್ಡ್ ಬಿಹೈಂಡ್ ದ ಮಿರರ್. K6, that is the ray diagram you should remember. K6 you have to remember, okay. The image is behind the mirror, right? So here it produces the magnified image, 3 times the magnified image on the screen if the object is placed 20 centimeter in front of the mirror. So in case 6 of the concave mirror, the object is placed in front of the mirror, which means it will come towards the left side. Only the image will come behind the mirror, that is towards the right side. So that object distance is 20 centimeter, which means u is equal to minus 20 centimeter. Then 3 times the magnified image on the screen means magnification. M is given. Magnification is given how much? Minus 3. 3 times because it is negative, right? Then how far is the screen from the object? How far is the screen from the object? Means you have to draw the ray diagram for this, okay? Now, see, you have a concave mirror. Now you have principal axis. Here you have pole. Here you have focal length. Here you have center of curvature. Sorry, this is principal focus, center of curvature. Remember, when you will get the image to be virtual and erect in concave mirror in case 6, in which condition you will get? In what condition? When the object is in between pole and principal focus. Only at this position you will get the image to be virtual, right? Now here see here, this is incident ray. One more ray has to go through the focus, extend this further. Then one more ray has to go and meet this principal focus, and the same ray, go and meet this virtual ray. That is, and if you are extending it, it should pass through the center of curvature. That's why it retraces the same path. Now this is the reflected ray and it is extended. Why? Because when the object is placed in between pole and principal focus of a concave mirror, image will not be real. Image will not be inverted. Image will be virtual, far behind the mirror, and erect as well as magnified. You can see here, A, B is the object, A dash, B dash is the image. Okay, see here, virtual, behind the mirror and magnified. Now, this image is 3 times the object, that is known as the magnification. Right? Magnification is equal to h2 by h1. So, the size of the image is thrice the size of the object. Idu 3 pattu ಜಾಸ್ತಿ ಇದೆ. ಯಾವುದು ಇಮೇಜ್ ಆಬ್ಜೆಕ್ಟ್ ಗಿನ 3 ಪಟ್ಟು ಜಾಸ್ತಿ ಇದೆ. ಅದೇ magnification. ಈಗ ಅವರು ಏನು ಕೇಳ್ತಿದ್ದಾರೆ question? What they are asking in the question? What is the distance of the image? What is the distance of the? How far is the screen from the object? Now see here, this is itself is the screen. This is only the screen. How far is the screen from this object? They are asking, which means you have to find here first what? Image distance you have to find. Then only you will get the distance of, you have to find one more, distance of screen from object. Let us, I teach you when I am explaining, okay? Now first find out V from the magnification formula. You know that M is equal to h2 by, M is equal to minus V by U. Right, minus V by U. Now you have M is equal to minus 3 is equal to minus of, you have V divided by U is given, that is minus 20. Now minus 3 is equal to minus divided by minus 6 plus V by 20. Cross multiply 23s are 60. So V is equal to minus 60 centimeter. V is equal to now here this M is equal to minus V by U. This minus sign is taken by minus M here, right? So what you have to do here? So since you have in this formula m is equal to minus v by u, this negative sign is taken by the magnification, that is given minus 3. So here only I have taken. So what I will do, that minus 3 or that minus sign, if it goes to the left side, you are left with only v by u, or I can even write this as minus m is equal to v by u. Okay, so what is this minus m you have here? That is minus 3 is equal to, then you don't know v, then you have u is equal to minus 20. Now cross multiply it. Okay, so v is equal to minus into minus plus 23 is a 60. So earlier I got minus 60. That is not the case. Why? Because image is far behind the mirror and you are moving the distance along the incident ray from the pole. So it has to come positive. So v is equal to 60 centimeter. Now you got the image distance. Now, what is the distance of the screen from the object? ಅಂದ್ರೆ ಏನೋ ಯಾವ ಒಂದು ಪರದೆ ಮೇಲೆ ಇಮೇಜ್ ಸಿಗ್ತಿದೆ, ಈ ಪರದೆ ಆಬ್ಜೆಕ್ಟ್ ಇದೆ, ಅಲ್ಲಿಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ, which means this distance of screen from object is nothing but v minus u, which means image distance minus of object distance. If you do, you will get the distance of the screen. You can ask me, sir, how did you write this? Now, just imagine, I am telling imagine this image, if it was at to the left side. Imagine that if this image was towards the left side, then you will get image here, that is a dash, b dash, then object here, that is a, b. Okay, just imagination. Imagine that image is towards the left side there. Okay, now this is object and this is image. Now this image is formed on the screen, right? Assume that the image is formed on the screen. Okay, now what is this? Now here is the pole of the mirror. Now this is the pole. You have to measure the distances from the pole, right? Now see here. You have to measure what is this distance, means what is the distance of the screen from the object. In order to measure this distance, first take this distance, that is from the pole from the pole to the image, that is image distance, that is v. Then subtract object distance, that is u. When you subtract this distance from the pole and this distance, you will get this distance, right? That's why v minus u. Okay. Now, so what you will get? V is 60 minus of what is u? Is 20. Okay. U is what? 60 minus 20. Now here you should not take 60 minus of minus 20. Why? Because 60 plus 20 will become 80. No, that is not the case. You have to take only the number itself. That is, what is that? Only 20 you have to take. Why? Because the distance of the screen from the object, not from the pole. So obviously distance should decrease. Okay. So 60 minus 20, what you will get? 40 centimeter. Very important. This was asked in 2017 CBSE 2017 paper. Okay, thank you. Okay students, moving to the 10th problem. This was asked in CBSE sample paper 2017. I just read out the problem. An object of height 1.2 meter is placed before a concave mirror of focal length 20 centimeter so that a real image is formed at a distance of 60 centimeter from it. Find the position of the object. What will be the height of the image formed? Now, the object of height 1.2 meter, given mirror is concave mirror. So, object height, that is h1 is plus 1.2 meter. He is placed before a concave mirror of focal length, that is f is equal to minus 20 centimeter. So that the real image is formed at a distance of 60 centimeter from it, means you are got V is equal to minus 60 centimeter, because image is real towards the left. Find the position of the object, means you have to find what is U. Then what will be the height of the image formed? Then you have to find out H2. Okay, you have to find H2. Now see here, given data, you have V, you have focal length F, and you can find U. Use the mirror formula, that the modified mirror formula. Therefore, we have F is equal to UV divided by U plus V. Okay, focal length is given minus 20 is equal to, you don't know U, then V you know, that is minus 60 U divided by U plus of minus 60. Now what you will get? Minus 20 is equal to minus 60 U divided by U plus into minus minus 60. Now cross multiply it. So what you will get? Minus 20 into U minus 60 is equal to minus 60U. Now bring the terms outside the brackets. Minus into plus minus 20U minus into minus plus 60 into 20 is 1200. 6 2s are 12. Okay, is equal to minus 60U. Now what you have to do? Bring this minus 60U to this side and move this 1200 to the right side. Now what you will get? 60U minus 20U is equal to minus 1200. 60 minus 20 is what? 40. 40U is equal to minus 1200, or U is equal to minus 1200 by 40. So 4 ones are 4 30s are 120. So since minus sign is there, U is equal to minus 30 centimeter. So object distance is minus 30 centimeter. Again you have to find out what height of the image. We know that is H2 by H1 is equal to minus V by U. You don't know what is H2. You know H1, that is 1.2 is equal to minus of what is V? V is given minus 60 by what is U? Minus 30. Here only you can simplify. 3 ones are 3 2s are. So H2 is equal to, now see here, minus divided by minus is plus. Outside the bracket is minus, plus into minus is minus. H2 is equal to minus 1.2 into 2. 1.2 into 2. What will you get? H2 is equal to minus 2.4 centimeter. So height of the image is minus 2.4 centimeter. Real and inverted image. Why? It is a concave mirror. Important question 2017. Okay students, let me go with the 11th problem. Just carefully listen the problem. A convex mirror used for rear view on an automobile. Automobile may be anything, car, bus, okay. So a mirror which is used as a rear view in an automobile is convex mirror. Has a radius of curvature of 3 meter. So for convex mirror, radius of curvature is 3 meter. Where does this radius of curvature will come? To the other side, to the right side of the mirror. Right side in the sense, far behind the mirror, to the virtual side, right? So we should take the sign convention positive. So radius of curvature, that is R, is given as plus 3 meter. If a bus is located, so if a bus, here bus is object. If a bus is located at 5 meter from this mirror, remember the ray diagram. Where will you draw the object? To the left side, right? To the left side of the convex mirror you are drawing the object, right? So you are taking the distance against the incident light. So the object distance, that is the the object, that is bus. So that is, you have to take it as u, that is negative. That is how much? If a bus is located at 5 meters, minus 5 meters from this mirror, find the position, nature and size of the image. And size of the image. Here, see, size of the image. Size of the image means what here? Generally, when you think of size of the image, you will go for H2. Because m is equal to H2 by H1. So, size of the image means H2. But, remember students, in order to find H2, you should know H1. Or magnification. Okay, out of 3, you should know 2 quantities. 1. If you are equating the ratio, H2 by H1 is equal to minus V by U, you should know 3 quantities, that is H1, V and U. Here, U is known, V we will find out, okay, we will get V, assume that we will get V, okay. Now we got V, we have U, then we don't know H1, how can you find out H2? So here size of the image is nothing but magnification. Size of the image is nothing but you have to find what? Magnification. Either it is neither height of the image, okay, nor any other parameter. It is nothing but the size of the image means magnification you have to find. Then also you have to find out nature of the image. Nature of the image. Okay, now let us proceed with the problem. Very interesting problem, I tell you, okay. Now, radius of curvature is given, object distance is given, you have to find out image distance. In order to find out image distance, as per the mirror formula, you should know 2 more quantities. One is focal length, the other one is object distance. Object distance is given, but we don't know focal length. But there is a clue here. Radius of curvature is given, you can find out focal length. Therefore, focal length F is equal to R by 2. Focal length F is equal to 3 by 2, which is equal to 1.5 meter. So focal length is 1.5 meter. Again it is positive side. Why? Because it's a convex mirror. All those are coming to the virtual side, right? So F is equal to plus 1.5 meter. Now you have focal length and object distance. You can find out image distance. Now use the mirror formula, modified mirror formula. F is equal to product by sum. Product by sum. F is equal to, then what is U? F is given. That is, we have found out F, that is 1.5 is equal to, U is minus 5V divided by minus 5, then plus V. Then cross multiply. When you cross multiply, what you get? 1.5 into minus 5 plus V is equal to minus 5V. Now multiply, okay, plus into minus, minus, what you will get? Minus 7.5, then plus 1.5V is equal to minus 5V. Now bring this minus 5V to the left hand side, then take this minus 7.5 to the right hand side. So what you will get? 5V plus 1.5V is equal to plus 7.5. 5 plus 1.5 is 6.5V is equal to 7.5, or V is equal to 7.5 by 6.5. You will get V value 1.13. So what is the V value that you are getting? You are getting 1.15. You simplify this, okay? Shift the decimal point. Using the powers of 10 you can simplify. You will get V is equal to 1.15 meter. Now V is positive. Why it has come positive? Simple, because it is a convex mirror. Image is formed to the virtual end, to the other side, that is far behind the mirror. So when you are measuring the distance, you are measuring along with the incident light. That's why it is positive. Now, nature of the image, as usual. You know, since it is a convex mirror, what is the nature of the image? Virtual and erect. Virtual and erect. Now, you have to find out the magnification, that is M. So, M is given by minus V by U, or M is equal to So we'll get minus of V, that is 1.15 divided by U, that is minus 5. So we'll get minus divided by minus is plus. So we'll get 1.15 divided by 5. So you will get how much? 0.23. So you get positive value. M means a positive value, that is magnification is plus 0.23. So this is the answer. Now what is the meaning of this problem? I'll explain to you. Hope you have understood this problem. Now let me explain here. Now you have a convex mirror, right? You have a convex mirror. You know the ray diagram in a convex mirror. Roughly I will draw. See, this is a convex mirror. Okay. Now you have the principal axis. Here is the pole, principal focus, center of curvature. Now you know that if you are having the object here, you are getting the image, virtual and erect image, okay, not inverted. So, but it is diminished. Somewhere here you are getting the image, okay. Now, where are the reflected rays? Actually, the reflected rays will be towards left side, right? Here you will get reflected rays, incident rays, and here this is incident ray means, or here it is incident ray means this will be reflected ray, right? These are the reflected rays. Where are the reflected rays coming from? Sorry, where are the reflected rays coming from? It appears to be coming from the focus, right? Like this. We will do the dotted lines. We have seen in ray diagrams. Now see here. This is object. AB is the object. A dash, B dash is the image. Now in this problem, assume that you are going in a bike. You have the rear view mirror, right? You will look the other vehicles which are coming behind your vehicle. Now see here. You are moving here. You are having the mirror. That is convex mirror. Okay. You are proceeding in this direction. This is the road. Dotted lines is the road. When you are going in the bike, in this mirror, okay, you are seeing the bus. At what distance is the bus? 5 meter. Okay, now see here. Here is the bus. Now see here, this is the bus which is at a distance of 5 meter. Actually, 5 meter, okay. If you don't see the mirror, then if you just see there, it is, you can easily tell that it is approximately 5 meter behind. But when you are seeing your mirror, your bike mirror, okay, how does the image of the bus appear? Image of the bus will appear enlarged. It is magnified. ಹೌದಾನೆ? ಹಿಂದೆ 5 ಮೀಟರ್ ಇರೋ ಬಸ್ಸು ನೀವು ಮಿರರ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ಒಂದು 3 ಮೀಟರ್ 2 ಮೀಟರ್ ಹತ್ರ ಬಂದು ದೊಡ್ಡದಾಗಿ ಕಾಣುತ್ತೆ. ಹೌದಾನೆ? ಯಾಕೆ? Convex mirror is called as what? Divergent mirror. Convex mirror is called as divergent mirror. You will get divergified image or divergent image. Now how this is possible? Come the reverse concept of this. Okay, why? Because you will get reflected ray only to the left side, not to the other side. This is far behind the mirror. Whatever we are doing here, it is all virtual. Now see here, this is the bus. Okay, now this is the bus. Now here you are going in the bike. Okay, this is your mirror. The object, the bus is at 5 meter. Okay, now this same bus, when you are seeing in the mirror, it appears magnified. See here, the same bus which is coming behind, it appears magnified. This is actually the reverse concept. Here it is image, here it is object. But to understand the concept, here you have to assume object and this is the image. Why? Because in this there is a virtual concept. Okay, you cannot go with the virtual concept in the reality. Understood? Now the same bus will appear very big, right? Like this. Now this is what you are seeing, okay, in the convex mirror. That is when you are moving in bike, this bus is appearing like this. So you will see that the bus in the mirror, if you are seeing, the bus is not exactly 5 meter, it is very nearby. It is just behind your bike. Like that you will see. So that's why these convex mirrors, they are used in rear view in automobiles. Why? Because you will get the magnified image of the whatever the object that is coming behind. So one of the best applications of convex mirrors. So hope you have understood. Thank you. Okay students, now we will move to 12th problem. Now carefully listen to the problem. An arrow, okay, an arrow 2.5 centimeter high, arrow is object, okay, is placed at a distance of 25 centimeter from a diverging mirror. So they have mentioned here diverging mirror. So diverging mirror means what? Convex mirror. So an arrow 2.5 centimeter high. So an arrow 2.5 centimeter high means what? That H1. Object is towards left side of the mirror, right? In convex mirror. So above the principal axis. So H1 is equal to plus 2.5 centimeter. An arrow 2.5 centimeter high is placed at a distance. Of 25 centimeter. Means U is equal to 25 centimeter with a negative sign. From a diverging mirror, that is convex mirror, of focal length. Now, focal length towards the virtual side, that is right side of the mirror. So, you will get what? Plus. So, focal length is how much? 20 centimeter. Of focal length 20 centimeter. Find the nature, position and size of the image. Find the position, nature and size of the image. You have to find H2 and nature of the image. Now, you have U and you have F. So you can find out therefore using mirror formula, that is the modified mirror formula. F is equal to product by sum UV by U plus V. F is 20 is equal to U is minus 25 into, you don't know what is V, you have to find out the image distance divided by minus 25 plus V. Cross multiply it. 20 into minus 25 plus V is equal to minus 25V. Then remove the or multiply the term within the terms in the bracket. So you get, so minus 20 into 25, what you will get? 500, right? Because 25 twos are 50, so you get minus 500, then plus 20V is equal to minus 25V. Then bring this 25V to the left side and 500 to that side. So we'll get what? 20V plus 25V is equal to 500, or 25 plus 20 is what? 45. You get 45V is equal to 500, or V is equal to 500 by 45. So what's our go at? 9s are. So V is equal to what? 1s are. .1. Okay, so what is the 11.1? You will get recurring. Okay, so you get 11.1. So the dimensions are in centimeter, so it is centimeter. Now see here, image distance is positive value you got, right? Why? This indicates that the image is formed to the right side. That means far behind the mirror. So positive sign. So we have found out V. Before going to H2, we can only get the nature of the image. What is the nature of the image? Nature of the image is, since it is convex mirror, virtual and erect. Virtual and erect. Now we have to find out what? H2. Therefore, we have H2 by h1 is equal to h2 by h1 is equal to minus p by u. So you don't know what is h2 divided by h1 you have 2.5 is equal to minus of v is 11.1 divided by u is minus 25. So yes, now minus divided by minus is plus. So h2 divided by 2.5 is equal to 11.1 by 25. So cross multiply it, what you will get? 25 h2 is equal to 25 h2 is equal to 11.1 into 2.5, or h2 is equal to 11.1 into 2.5 divided by 25. Now here what it will go? 25 ones are 0.1. So 11.1 into 0.1, you will get the value of h2 is equal to 1.11 centimeter. What you will get? 1.11 centimeter. So you are getting positive value plus 1.11 centimeter. Why? Because the image is formed far behind the mirror, virtual image and magnified image, right? So that's why you will get plus 1.11 centimeter. Here, sorry, the size of the image is plus 1.11 centimeter, means reduced image. Okay. Okay, students, you please take down some homework problems. I have given 4 problems. I'll just dictate slowly. You can even see on the board. First one. Radius of curvature of a concave mirror is 25 centimeter. What is its focal length? Second one. A concave mirror produces 10 centimeter long image of an object of height 2 centimeter. What is the magnification produced? Third one. Find the size, nature and position of the image formed by a concave mirror when an object size of 1 centimeter is placed at a distance of 15 centimeter. Given the focal length is 10 centimeter. Fourth one. An erect image 3 times the size of the object is obtained with a concave mirror of radius of curvature 36 centimeter. What is the position of the object? So please do all these 4 problems.